All right, let's go ahead and get started. So I'm excited to introduce our last speaker of the semester. So last but certainly not least is Nat Shear. So Nat Shear works as a consultant in, a senior consultant in information security at Rook Security. So he has his master's from Columbia University, and he works on application penetration testing, network penetration testing, and social engineering. So it should be an exciting talk today. So I'll give it to Nat. Thanks.
Yeah, thank you very much. All right, good afternoon. As you said, my name is Nat Shear from Rook Security, and today I'm going to talk about penetration testing. Right? Why is it? What is it? Why is it so important? And how it's performed. First and foremost, a little bit more about myself. You already covered most of this, so I'm a senior information security consultant. I've been with Rook Security for a little bit more than 3.5 years now, and these days I lead our web application hacking and penetration testing service. Also do a lot of network, social engineering, programming, both in the job and on the side as well. So most of my days and most of my weeks are spent performing various hacking activities and performing penetration tests, right? So what is a penetration test? Simply put, a penetration test is a controlled way to perform security testing from a hacker's perspective, and that makes it unique from traditional functionality or security testing. And generally, penetration testing falls into 3 general categories. And that depends on how much information the testing team has before they start the project, before they start the engagement. With no information, that's called a black box engagement or a black box penetration test. No information is provided. You essentially just have your target and have to do all the reconnaissance and information gathering on your own. On the complete flip side, you have white box penetration testing. Any and all information that the testing team might want or need to fulfill the engagement, they are provided. That could be developer documentation, source code, even sometimes password hashes if that seems necessary for the engagement. And then in the middle, the hybrid of the two is gray box. You have some information, but not all of the information. And really the type of penetration test that you would go for depends on your goal. If the goal is to simulate as closely as possible a real-world external attacker, you're looking at a black box approach. If your goal is to enumerate every possible vulnerability, no matter how likely or unlikely it is to actually be exploited, you're looking at a white box. And obviously, if it's somewhere in between, then it's a gray box. So that's what it is. Why is it so important? So like I said, it provides that hacker's perspective, but without the risk of actually getting hacked. And that hacker's perspective is very unique for a penetration test as opposed to traditional security testing or functionality testing. With traditional testing, you're trying to verify that the application, generally in my case, or the functionality is working as it is designed to do. In a hacker's perspective, you're trying to verify whether you can make the application do something that it's not designed to do. And that kind of out-of-the-box thinking is where that hacker's perspective comes in. If you've been familiar with or even joined a bug bounty program, that's very similar, same kind of thing. Penetration test is basically that, but without the public involvement, so you know who's performing the testing. A couple other reasons why you might perform a penetration test. It determines the business risk and impact of identified vulnerabilities. I know you had somebody come in and talk about vulnerability scanning earlier this semester. So very often one of the questions we get asked is why perform a penetration test over just a vulnerability scan? Well, a vulnerability scan will tell you, yes, there is a critical vulnerability on this server and that server, but it won't tell you what you can do with that vulnerability. If that server isn't connected to anything, there's no information on it, then yes, it's a critical vulnerability, but from a business perspective, we don't really care. The penetration test can tell you, yes, it's vulnerable, and we exploited it, we got system domain admin access, and now we control your entire company. Other thing is testing security defenses and the response teams. If you have a security operations center, then this is a good way to see whether the security operations center is efficient, if they can stop the attack, and the various methods that the penetration test might take to exploit the network or the application. And finally, remediation efforts. Ultimately, any security testing is designed, the goal is to remediate, to become more secure at the end than you were at the beginning, so helping with that remediation efforts and best practice implementations is very important as well. So that's what That's why. So now we'll get into the meat of it, and which is how is a penetration test performed. Now, before I talk about this, penetration testing is hacking, which is illegal if you do not have express written permission from the owner of whatever asset you are attacking. So please, anything that we talk about here this evening, do not try this at home. All right? With penetration testing, there's a lot that goes in around your just traditional hacking, right? The hacking is the fun part that everyone really enjoys, but for a penetration test, there's more to it. You're trying to provide real value to the customer, to the client, or even to your own company for internal penetration testing teams. So first and foremost, in order to make sure that you're not doing anything illegal, you define two things. You define scope, and you define the rules of engagement. The scope is to make sure that, yes, this application, this subnet or network is in scope. That's what I'm going to target. This office building, these employees are not in scope. If we start targeting them, that's illegal. Rules of engagement, same kind of thing. We are going to perform application testing, we are going to perform network testing, but we're not going to perform social engineering, or we're not going to try to get physical access to your office and plug in a USB to your data center, those kinds of things. Executing an engagement. So once you have the scope, once you have the rules of engagement, now you can actually get into hacking. That's the generally considered the most fun part, the best part. But after that, once you're complete, it's not enough to just say, oh, it's vulnerable, good luck, make sure you call your lawyer. Ultimately, what you want to do is, again, make them more secure. That's where that report comes in. I talked about bug bounties earlier. It's not enough. They will not pay out for bug bounties if you do not provide a written, detailed technical report explaining how your process worked, detailed steps so that they can recreate the issue and prove and validate to themselves that it worked. And those generally, executive summary, technical details, all very important to show, yes, this is what happened, this is how you fix it, and all that kind of things. And then, of course, remediation, retesting, also very important. We've had clients in the past who looked at our steps, 1, 2, 3, this is how we exploited the vulnerability, but generally those fall into the category of proof of concepts. We're not doing anything truly malicious. So from the application standpoint, cross-site scripting is very often the proof of concept is a script tag, alert script tag, so you just pop up an alert box in their browser. Relatively benign, but it shows, yes, I was able to execute JavaScript. So we had a client that looked at this and said, okay, we'll fix that. They came back 2 weeks later and said, we fixed it. We took a look. Yes, they filtered out script alert script, but they didn't filter out script prompt script or script, download malicious JavaScript file script. So that retesting to make sure that, yes, it was truly remediated can be very important. Okay, but now to the actual hacking. The attacker methodology. When you're approaching a penetration test, these are the basic steps that you're going to walk through. First and foremost, reconnaissance, right? Particularly with black box engagements, you have no information. All you have is a domain, a URL, or even just IP address and ranges, right? So you need to do reconnaissance and make sure you have all the necessary information to start with before attacking. Because as soon as you start interacting with that application, with that network, now everything that you're doing is being logged and monitored. So you want to make sure that you get to the exploits as quickly as possible and get out before they stop you. Attack, that's where, once you've got all the information, you perform the attack, you perform the exploits. Privilege escalation, if you get access, this is more common with, network hosts. So if you get access to a user's account, you get into the network host, okay, but you're a user, now you want to escalate your privileges up to a system admin or an administrator. Gaining a foothold, right? Hackers have to sleep too. They don't want to wake up the next morning and have all their work go to waste, so they try to create a foothold, generally some kind of reverse tunnel that they can get back into the any servers or applications that they have exploited. Data exfiltration, right? Retrieving the information that you have stolen out of the target network, and then cover tracks. For penetration testing, we always skip cover tracks. Besides for maybe 1%, but for the most part, 99% of the time we're going to skip covering tracks because we want them to become more secure, right? We want a client, a customer to be able to look back and say, yes, I see what you did here. I'm seeing the logs. I'm seeing what happened. So now I know for next time how to stop that. And that's what's most important. We want them to be able to take those and collaborate them with the report that we provided. So walking through each of these then, we start with reconnaissance. Any time you're going through reconnaissance, first place to start, social media, right? Companies publish tremendous amounts of information about themselves. People publish tremendous amounts of information about themselves. This is the best place to start, right? Facebook, LinkedIn, Twitter, you get all kinds of information, backgrounds on the company, where it's based, when it was founded, how large the company is, different job requirements, right? If they are looking for an Oracle administrator with 10 plus years of experience, it's probably a good bet that they've got Oracle databases. So that helps, again, understand and tailor your exploit scripts. The different skills that their employees might have. Again, if they've got Oracle, if they've got Linux, it's a good indication then that in their internal network they've got Oracle databases and Linux servers. From social media, we'll then go to more general information that they didn't necessarily publish on their own, right? This will be Google hacking techniques. Anyone know the power of search engines such as Google, such as Bing? Using various tags, you can find information that people sometimes don't even know is online. The most problematic example is passwords. This happened a year and a half ago, 2 years ago. I think an article came out about Microsoft's equivalent of Google Drive. Some people were publishing documents that they thought were private, but were actually shared with the entire internet. And there were lists of people's passwords. They were writing them down, and whole credentials that people could search for on Google and find if they just knew what kind of pattern to search for. And exploit-db.com, you can actually look. They have huge lists of various search parameters that you can use. It's called the Google Hacking Database for the most popular search engine, Google. Shodan is the search engine for the Internet of Things. You put in an IP address, and it'll tell you what ports are open, what services are running, all without interacting whatsoever with those target networks. Intel Techniques is one of my favorite. It has lists and lists of various websites that you can use to search for people, usernames, email addresses, domain names, all kinds of things. And for applications specifically, one of the most common that we use with every engagement is builtwith.com. You can put in the URL of the application that you want to target, and it gives you the full list of every technology that that application is using before you even touch the website. So now you know all about the company. Now you might start targeting the employees themselves. You identify, first and foremost, the email formats. Why is that important? Because that email format is very often the username, the corporate username on all of their corporate accounts. Doing a quick search, I used Rook Security as an example. Doing a quick search for Rook Security in email format, you get Rocket Reach, and it correctly identifies. Email format is firstname.lastname@rooksecurity.com. Well, now just with an employee's name, you now have their email address. No more searching required. With that email address, you can go to websites such as haveibeenpwned.com and see if that email address has been associated with any data leak credentials that have been leaked in data breaches, and it gives you a full list. Have I Been Pwned is a legitimate service that does not give you the password hash. It'll just tell you whether the email has been found. It's supposed to be used for yourself to verify, has my password been lost? Should I be changing my passwords, and in what services, and those kinds of things. But if you know somebody else's email address, you can search for it as well, and then you'd have to download that data breach separately and search for the password hash yourself. And then security questions. Web applications still use security questions all over the place, so we look for the answers to those security questions. You can see I searched for myself here on mylife.com. Not all of that information is accurate for anyone looking very closely at it, but you could start using that, collaborate it with a couple other websites, and build a profile including dogs, mothers' maiden names, birthdays, and all kinds of things like that. Once you're armed with all of that, right, companies, people, now companies, people, sometimes even employee credentials, before you even interacted with the target network, with the target application, with the target company, now you're all set for that attack phase. Now, if this does sound like a lot of work, particularly if you're looking at a company with even a couple of dozen or 100 or even 1,000 of employees, it is a lot of work. But there are a lot of good frameworks out there for automating a lot of the reconnaissance. I just listed a couple of my favorites. ReconNG full-featured reconnaissance framework written in Python. The developer of that framework presented at Black Hat a couple of years ago and used FBI.gov to show how you could go from just that domain to emails and clear text passwords for FBI employees. Not showing that here, but it's an excellent video. A couple of the other ones, Aquatone is one that we use all the time for web applications. It searches for domains. You could have, rooksecurity.com. You put that into the program here, and it'll find all the other domains associated. For example, info.rooksecurity.com, blog.rooksecurity.com. Sometimes even, prod or dev or test.rooksecurity.com. Those kinds of things can be identified as well. Okay, so that's your reconnaissance. Once you've gotten all of that, you've gotten all the information that you can identify, now you're moving into your attack phase. Types of attacks. You've got your technical and your non-technical, and those are very high-level categories, but that's basically what things fall into. And I don't mean to take away too much from email phishing. Email services can be very, very technical, and I know one of my coworkers does a lot of technical work trying to set up the domains so it looks legitimate as possible. But in general, phishing attacks or social engineering attacks are considered non-technical, whereas network, web app, VPN, right, lets you write into the internal network, mobile, all those kinds of things are a little bit more technical. And I'll jump into a little bit more on each of those. So for technical attacks, your most common, of course, is going to be network and web applications. Network, you start with port scanning. If any of you have ever used the Nmap port scanner, that's a good open source tool. You can download it very quickly, get to running, see what ports are open, what services are open, or what services are running. Nmap even has a lot of the plugins that they can use. You can almost do a full vulnerability scan with Nmap these days. But if you want the next step, so then you go to vulnerability enumeration. Once you've identified the services, then you start identifying what's vulnerable, what version numbers those are running. I know you had that talk a while ago. And then exploitation. Metasploit is one of the big frameworks for performing exploits. Exploit-DB, I mentioned that before. Huge database of available exploits that the security community has written. And then man in the middle. Sometimes you just find the right network, either internally or at a coffee shop. Sit there sniffing the traffic, wait for your target to come in. And just wait for him to access a plain text website, or set up a spoofing attack for the wireless that you can manipulate and get those credentials like that. For my service, web applications, the OWASP Top 10 is a powerful document. If you haven't looked at it, details the top 10 most common vulnerabilities identified in web applications. And again, it's high-level categories, but it's a very good document. They've come out just recently with an updated version for 2017. They did have an updated version, I think, in the summer, but it didn't make it past the peer review stage, so now they've come out with a new version. I think it should be going public relatively soon. Back-end API requests, very often developers think, okay, I've got the main site, and I'm going to do all my data retrieval via API requests using JavaScript and XML, HTTP requests and those kinds of things. They think, oh, well, because you're not using it in a URL, the user never realizes that those things are going on. Technical people do, yes. For testing, I set up a proxy. We see any network traffic that's going on as part of that web application. Those back-end API requests are one of the first things we go for. And various tools that we use. Burp Suite is my favorite, but OWASP Zap is a tool published by OWASP, and that's free, totally free and open source. And Dirbuster, Arachne Web Scanner. Dirbuster is one of my favorites because it's a bit of a little-known technique that can be used. Essentially, you take a large word list of various types of files, various types of directories that are common on web applications, and just start trying them, right? If you get a 404 status code as a response, that means it's not there. No big deal. Keep trying it. If you start getting 200 or 403, now you know, hey, that might not necessarily be linked in the web application. Sometimes you find test files or backup files or other kinds of things like that are on the server but aren't linked in the web application, and the developers or the administrators thought, well, nobody's going to be able to find them because they're not linked. Over to the non-technical attacks, the social engineering, the primary ones that we implement: email, phone. I'll get to physical in a second. Right, email campaigns, you use domain variations to make it look legitimate. Right, slight misspelling, slight grammar mistakes are very common for email phishing campaigns. Using malicious attachments, phishing pages, pretending to be someone else. If you've seen the news fairly often, right, somebody sends an email pretending to be a CEO of a company, says, "I need all of our employees' financial documents," and sometimes they send them right over. Turns out, oh, that actually was not the CEO. Phone phishing, we've done this successfully fairly often, calling the user, asking calling as a user, asking for a password reset. Sometimes you call, you just say, "Oh, I'm John Smith," and they say, "Oh yeah, what do you want your password to be?" I said, "Okay." Calling as an employee, pretending to be the help desk. This one we generally try Friday afternoon when nobody wants to talk to IT at that point. Right? We call and say, "We're going to be resetting everyone's accounts over the weekend. We just need to get in there. We can either bother you over the weekend, or you can just give me the password right now." 9 times out of 10, they just give the password right now. Or calling as a third-party vendor. If you've ever gotten a call from Windows support from a number that clearly is not Windows support, that's the kind of thing there as well. And then, go ahead.
So I'm curious, after you mount a social engineering attack like this, like phishing, say some fraction of the employees in an organization fall for it, do you then use that as an opportunity to educate the employees at the organization where you're doing pen testing, or what's the fallout after an employee does fall for such an attack?
Most commonly, we offer social engineering just as a service. So we'll send, an email phishing campaign, or we'll set up, phone phishing, and then just collect the information that employees provide it to the IT administrator who hired us, and say, "This is, a problem. You need more education around these topics." But our preference really is to use this as part of a bigger penetration test. So we're trying to get into the network. We're trying to do various technical things. We're not having much success there. So we'll say, okay, we'll send out a general phishing campaign to the employees. We say, "Sorry, we have to reset everyone's accounts, everyone's passwords. Here, click this link. It'll take you over to the reset password portal." It sets up, and then all of a sudden, they put in their original password. They think they're changing it. We get the original password. We go log into all of their services and applications, and now, we've got access, and we go from there. See what else we can get.
One more question, I guess, following up. So, how much do organizations regulate, what you can collect or store, from a phishing campaign?
Less than you'd think, actually. Generally, we have various agreements and various legal documents in place. So when we collect passwords, we ensure that they're stored in a safe place. Only we have access to them. And then, almost immediately, particularly for where it's just the social engineering service, we say, this employee clicked, this employee submitted their password. Please go immediately change. Tell them to change that. We don't take that. We delete it afterwards, after the engagement is over. We don't go to anywhere else. Cover it a little bit more later, but password reuse is a terrible security problem. We don't try that person's Facebook or LinkedIn or anything like that. So basically, as few people as possible have access to it, and we try to get them to change it as soon as possible. Email, phone. There's also, of course, physical attacks, right? Honestly, our most successful is just tailgating in. Sometimes you can just walk right in. If there's a badge access that needs to get access to the door, to the office, if you just come up right behind somebody, everyone wants to be helpful. They'll hold the door for you. If it's a particularly secure office, so you just carry a big empty box and it looks like you can't reach your badge, so then they'll hold the door open for you, even if they wouldn't have normally. If that's not going to work, sometimes we've put various technology like exploit stuff for the network in UPS boxes. We show up, we say, "Here, we've got a package for so-and-so." We know that they're not there that day, so it'll just be put on their desk and it'll be running in the background, hopefully where nobody notices. Fire building inspector, this was particularly successful. We showed up with clipboards. That was basically all clipboards and a polo, and said, hey, hi, we're here to inspect the fire extinguishers. Can we get access to the building? And they said, oh, absolutely. Here's the master key. Go wherever you want. So that's basically physical. So now get into a couple more technical examples. Jumping over to application testing, because that's generally my service and what I know best. SQL injection, very common, still very common, even though it's published a lot in all kinds of documentation. Still number 1 for the OWASP top 10 most common vulnerabilities. And it basically comes down to either old software or just developers who don't realize the problem. So here's a very easy example. You can actually go and demo this at codebashing.com at that URL there. It gives you a login portal. It shows you the code right in that in the middle there where it says the string SQL. You can see that they're integrating the email and the password right into the code without filtering, without sanitation. You try a single quote. You try a double quote. The single quote breaks everything. You have an error. Double quote, cleans it again, and the query works just fine. That immediately tells you, I can use SQL injection here. You put in the quote or 1 = 1, defaults to true, comment out the rest of the query, and you are in. One of the most common vulnerabilities for applications is cross-site scripting. This comes down more to within the application itself, within the browser. You're using the HTML, using the JavaScript, it's just not sanitized. People don't expect this type of attack. So for one of the common avenues here is a search box, right? Very often they'll say search here. You click search and says, I'm sorry, I didn't find your search query, right? Repeats it right back at you. Anytime you see your input reflected right back at you, it might be vulnerable to cross-site scripting. And here you can even see on the bottom right there, sorry, no results were found for, and then right there you've got the query. No sanitation, no filtering. You put in script alert script like that, boom, you've got an alert box. Now again, that's just a proof of concept, but once you've got JavaScript, once you can execute your own JavaScript, you can start doing much more malicious things. For a client at one point, we had this same thing. It was a login portal. Well, not the same thing. It wasn't a search box. It was a login portal, and they used a URL parameter to provide the error message. But they were not sanitizing it. They expected that error message was always coming from their system. We put in a script tag that changed the target for the login form. So as opposed to sending the username and password to their server, it actually sent it to our server. And as soon as it was what's called reflected cross-site scripting, so if you click, so it didn't change the actual website, but if someone went to that website from the link that you provided with your JavaScript in it, then it would change their login form. As soon as they tried to log in, we would get their username and password and not the server, and then obviously we redirected them from there to your basic, oh, sorry, that didn't work. Missing authorization is another big one. If I had $1 for every time I just changed the ID number and got access to somebody else's profile, I would be a very rich man, and it makes me very sad every single time. Another example, I talked about that directory busting thing before with Dirbuster. Commonly, developers think, oh, if I don't give you the link to follow, you're not going to be able to find the different functionality. However, you can very often see /user/menu. Well, if there's an administrator, what if I try /admin/menu? And if that brings you right to the administrator functionality, that is missing authorization. Both of those very common mistakes that we see and very commonly exploited for problems. Back over to phishing. So here's an example of an email that we actually sent. This was a test email, so you see my name on it, but it looks really legitimate from American Express. Even the domain actually is legitimate, but we used a proxy, sendgrid.net, to send it from. And then when you click on the click here to review recent transactions, of course, takes you to our spoofed American Express login page where then we are harvesting the login credentials. Another one for Google Drive. We actually used a Google Drive campaign the same week that a huge news story broke out about a general Google Drive phishing attack. At first we thought it was us. We were really flattered. Turned out it was not, but that's okay too. But then if you click on the link, of course, it brings you to a phishing page that's asking you to log in for credentials. Very often, either the domain is wrong, and that's one of the example. The next one, the domain is wrong, right? So this looks like Outlook web app, but you look at that domain up above and it's in Amazon. Big red flag there, obviously. And one thing that people very often think is, oh, if it's HTTPS, that's okay. But here you can see also, it's HTTPS, but it's clearly in Amazon. HTTPS does not guarantee your security there. But back to the other one for Google Drive, you don't have the domain here, but you can clearly see some problems here. I don't know why you can log in with your Yahoo credentials to your Google account. Bit of a red flag there too. Again, another one. This looks like OneDrive for Microsoft, but it's hosted at formbuddy.com, clearly running a Perl script. Those kinds of things there. Next level, as opposed to just phishing campaigns or phishing emails, we'll send malicious attachments, right? Executable files, infected PDFs. Microsoft Office macros. These are actually making a bit of a comeback. When they first came out, people understood that there was a security problem. And generally, they were not discontinued, but nobody wanted to set up macros. But now it's been kind of dormant for so long, people are starting to trust them a little bit more these days, and we've had some success with those as well. Executable files. So this was a bit of a gray box engagement. The client told us that they'd recently had performance reviews, so we sent their employees a file.exe, which was supposed to contain the results of their performance review so they could review it. We had about 50% of their employees try to execute our executable file to see their performance reviews. Our favorites were actually the ones who executed it multiple times because they didn't think that the error box that we had pop up was really convincing. Rats, remote access Trojans, again, that goes back to gaining that foothold. Ransomware has been really big in the news. We don't do any of that. Too many problems can arise if you can't decrypt the files or anything like that. So we don't touch that as part of penetration testing, but that's also the same idea there. So that's all the attack. Once you've gotten the attack, now you're trying to escalate your privileges. For web applications specifically, one of the best ways to do that is BEEF. It's the Browser Exploitation Framework. And basically, it uses JavaScript to execute malicious activities. Very often, it can do all kinds of things, and it's got a whole framework for it with tons of different good modules there. Exploiting operating system vulnerabilities, that's more on the network side, right? Once you've gotten SSH access, for example, whether brute force or by exploiting a vulnerability, then you get into the operating system. But if you're a standard user, you have to escalate your privileges in order to do anything interesting. So that's becoming root system or pivoting to other hosts inside the network. If you're coming from the external network, now you're trying to see the internal network. Internal network is generally much more vulnerable than the external. So a quick example here of a foothold. This was done in a sandbox environment. I can't say that this was actually done on a client network, but because this was, we were doing a little bit of research, this particular rat, this Trojan, we had seen and had been causing some havoc. So we were trying to understand it a little bit more. So this is the victim's perspective here. And he's in his email doing his business, and all of a sudden he gets a email from somebody. It looks legitimate, right? He trusts this guy, and it asks him, hey, can you help me out here? I'm having some problems with my database. So he jumps in. He opens it. It's encrypted because this was a known malware pattern. So antivirus was already blocking it. But he trusted the email. The email gave him the password to decrypt it, right? And that decryption was to avoid Google detection and to avoid antivirus. So he decrypts it. He tries to open the PDF. Obviously, nothing happens. He doesn't see anything. He just thinks it's broken. He tries a few more times. Once he's unsuccessful with that, he gives up. But he's even a nice guy. He sends a note back saying, oh, your PDF wasn't working. You know, I'm so sorry. Give me a... Getting ahead of it. Your PDF wasn't working. I'm so sorry. You know, reach back again, you know, and I'll try to help you as much as I can. Fine. He sends that off. He thinks nothing else of it. He goes on with his day, with his business, right? He jumps into the SQL server that he manages and starts looking at all the various data in there. This is a sandbox environment, so don't worry about it. He even thinks he's very secure, right? Because he has a unique password for that SQL server. He uses KeePass to save all of his unique passwords, and they're all super complex, right? Nobody's going to be able to brute force his passwords. So he logs in, he starts doing some SQL administration, jumping through the various tables and columns and doing some searches, right? Business as usual for him. But in the meantime, from the hacker's perspective, the hacker sends that email with the attachment of the PDF that he encrypted. This is essentially the other side of the coin. This is what, as a penetration tester, this is what you would be looking at. You send the email, and actually waiting for that email to be responded to is one of the worst times, because you think, well, did I get detected? Is this over? But in this case, no, the administrator executed it, and now he has a remote access Trojan on that computer. Even though to the administrator it looked like nothing happened and it was just broken, he now has full control. And you can see on the side there all the various things, all the various modules that this particular Trojan has installed as part of it. First and foremost, capturing screenshots, just watching the administrator's computer there. But then he pulls up KeePass. Right, it's not going to show him the password. The administrator just copies it and pastes it into the database login. So he sets up the clipboard module and says, "Show me the clipboard that this guy has." And from there, he gets access to the password. Yep, there's the clipboard. Shows the password that the administrator is using. And then he can, once he has that, he doesn't need to really watch anymore, but he continues to watch, gets full listing of all the various tables and columns there, as well as, he can see the various user entries as well. So you've gotten your foothold. Now you're trying to exfiltrate your data, right? We always ask administrators. Oh, go ahead.
So the brief is that can this happen even when you're working in companies like the big companies where they have all the secure systems? So because the way I've shown it, since it's encrypted, it will be difficult for Google or any other mailing service to detect it. So let's say you're working in an organization as such, you get such an email and you open the document. Will the whatever services still be able to detect such things?
Will the Trojan be able to run, or will it be able to be detected?
Yeah, I mean, will the systems that they're within the company, will they be able to detect that, or?
So it depends, right? Do I have, or before, sorry. If you've heard of Virus Total, it's an excellent website. You can actually upload a file and it'll run it through all various antivirus. I think it has 60 to 70 antivirus services that it uses, and it'll try to tell you whether this is a malicious file or not. It's used for technical IT people to upload files to try to see is this something bad. The problem is hackers have access to this service too. So before they send the Trojan to the target, they will upload it to this. And if it gets flagged by even one antivirus, 9 times out of 10, they'll take it down, start reworking it, right? Trying to make sure that it doesn't get caught. That's a bit of the problem with antivirus specifically. It's looking for patterns. As soon as that pattern changes, it treats it as benign. And for most people, if it doesn't get caught by antivirus, they think it's okay. So can it happen? Absolutely. Does it happen? Depends. Does that answer your question?
The reason I was asking was because this doesn't happen quite often when you're using a company's laptop or something like that, right? When you're using, there weren't much cases where people get breached by such type of scams.
Mm-hmm.
So is there anything which all of these companies will use in particular against such attacks, or?
Yes, antivirus first and foremost. Very often they will have email protection as well, right? Secure email or other things. It's called endpoint protection. It's the phrase that I'm looking for. That will try to help with this as well. We had a client that hired us to try to perform these types of attacks. They did not allow any attachments to be sent via email, which was obviously a problem for us, right? It was an excellent. We were happy to see that. But those kind of things. So you can, but it comes back to the basically security versus usability. If you can't send any attachments via email, that really hinders your ability to do your business, right? Sending Word documents, text files, PDFs, that's generally a very big part of using email. So you can be more secure, or you can make sure that your users are happy, and it's that constant trade-off that you're always looking at. So then you've gotten your passwords, you've gotten your footholds. Now you're trying to exfiltrate your data. So we very often ask administrators, okay, you're monitoring your network. Would you see a huge spike? So suddenly, normally you have 5 gigabytes or so coming in and out every day. It's not that much. That would be a pretty small office. But would you notice if it suddenly jumped 200, 300%? Very often, the administrators say, yes, we would notice that, right? We'd get an alert, we would see that. And we say, okay, well, what about a steady, small stream, right? 5 kilobytes at a time. That wouldn't cause any spike whatsoever. But it's constant, every couple of seconds from the same computer. Would you notice that? And now, most people say, no, we would not notice that. So that's the kind of things for a skilled attacker, they're going to take things out very slowly. They're not going to overload you, right? They want to, again, cover their tracks, right? We don't do cover tracks because we want to make sure that they are able to figure it out afterwards. But if we are trying to avoid detection, we'll exfiltrate the data very slowly. And then there are unconventional methods as well. So as opposed to just kind of downloading all the information, there are unconventional methods. Using private Twitter messages is an interesting one, but my favorite that I've seen recently is exfiltration through emojis. It's essentially an encryption algorithm, not a super advanced encryption algorithm, but it takes the data that you're looking at, say for example usernames, emails, passwords, social security numbers even, and translates it into a text file of emojis. Or they even have a module for just lists of Pokemon names, for example. And then you exfiltrate that. Once you get it onto your side, you can basically decrypt the information. Now, this is not obviously a strong form of encryption. If they get access to that file and they have the program, they can decrypt it as well. That's fine. The idea here is to avoid detection, avoid any pattern matching for passwords or social security numbers and that kind of things. Generally, nobody cares if people are taking out Pokemon names. And then a number of other interesting ways as well. Don't really have time to go into all of those. And then for general hackers in general, they'll very often cover tracks, which means deleting any malware or files that they downloaded and set up on the computer, accessing and editing the log files. Generally, you won't see the log files deleted. That's a big red flag if your log files suddenly disappear. But if you just jump in there and take out an entry or two, for the most part, nobody's ever going to notice that. Using Tor and other encrypted channels, right, so that attack can't be traced back specifically to a source IP. Public access points, right, Starbucks, you set up, do your attack, it's a public network, and it could have been anybody. And then anonymous services and profiles, right, the hacker's not going to register for your application using their name and their personal email address. They'll set up dummy profiles and use those instead. So that covers all the different aspects, right? Reconnaissance, from reconnaissance, attack, escalating your privileges, all the way down to foothold and covering your tracks. It would be remiss of me if I didn't then talk about a little bit about protecting yourself, protecting the company if that is relevant. First and foremost, our SOC manager recommends enable two-factor authentication on everything. Any possible account or service that you can, enable two-factor authentication. One of my coworkers actually, this saved his Facebook account because he had set it up long ago. He just jumps right back in and never asks him for his password again because he's always in there. It was an old email address. It was an old password that he never really updated. All of a sudden, he gets a notification from Facebook says, "Oh, someone's, here's the code that you asked for logging in." And he said, well, I'm at work. I didn't ask for this. Turns out somebody had gotten a hold of his password, tried to access his account, but because it was two-factor, he was able to turn it off, shut it down, and then go and change his password before any harm was done. My personal recommendation, WOT was World of Trust. That makes sure that the domains, that checks for phishing pages and other kinds of things like that, makes sure that those are legitimate. And then a password manager. Using unique passwords to avoid the same password in all the different applications, right? Because then somebody gets a hold of that password. If it's in a data breach and somebody gets a hold of it, or just through phishing, somebody gets a hold of it, they now have access to your entire life on the internet. But if you use a password manager, use unique passwords throughout your different services, then if somebody gets a hold of one password, they get a hold of that one service. And then double checking domain from address. If it's going to be spoofed, it'll show up, right? So you can look at the from and to make sure that, yes, that is legitimate. Number of times I've gotten emails from what looks like my grandmother, but as soon as you look at that from email address, it is clearly not my grandmother. Think twice before clicking through an email. One of the big recommendations that we always say is, if they give you a link to Amazon.com, why click the link? Why not just open a new tab, type in Amazon.com, and go from there? The problem you have there is if there are various tags at the end, to tie it to your profile. So then maybe you have to, click the link and try. Maybe you do have to click the link, but very often it's just an article or something that you can just browse to directly. And then for the passwords, if it's not a password manager, think passphrases instead of passwords, right? A one-word password, even if you add an exclamation point or a number at the front or end, right? Hackers know those tricks. But if you think a passphrase of 3 or 4 words put together, it just makes it that much more difficult for somebody to guess or for somebody to identify. And that is essentially penetration testing. Remember the hacker's perspective and the what, the why, and the how. Any questions? Sounds good. Looks like I covered it all.
All right, let's thank Nat. Don't forget to...
Just a quick question.
Yeah.
How have you run into problems, particularly with the phishing attacks, where there is pushback after the fact, or the people pushback on the people who contracted you in doing that?
With phishing attacks, no. I don't think we've ever gotten pushback to an extent like, oh, we did it unfairly or something like that.
Well, I know of some research projects in phishing where basically, even though nothing happened, there was no repercussions on employees, and they'd even been warned in advance that this might happen. There were people who basically caused the research project to be shut down because they didn't like being told that, or they didn't like having it pointed out that they were doing a bad job of security.
I definitely hear that. No, I don't think we've ever had pushback after the fact. But again, with the rules of engagement, we always make sure that we're all on the same page before we even start. So if they say, yes, you can do social engineering, I don't think we've ever had pushback afterwards. But we do, majority of clients do tell us not to do social engineering as part of penetration tests.
I was not so much that I would expect you to get the pushback on the social engineering, but that the people within the organization who've hired you would have others in their organization complaining that they shouldn't have done this. And I'm surprised you haven't had that.
That I guess I wouldn't have insight to. We did have a client where when we were discussing performing social engineering, they had to get not only their IT team, but their HR department, I think their legal department, and even their finance department all in a room, with us to discuss whether this was a good idea and the parameters and all that kind of thing. That was what should have been a 1-week project turned into a month and a half easily, just trying to define those parameters. But yeah. The pushback that we get the most is after just basically application testing, and we say, oh, this is vulnerable or this is an exploit, and the developers come back and say, no, that's how it's designed to be. We wanted it that way. And we say, no, I don't think you wanted it to be able to access other people's profiles. And they say, that's where we get the most pushback. Yes?